The Carbon Infrastructure Transformation Tool project is essentially about reducing emissions in the infrastructure sector, and more specifically it's about developing an embodied carbon calculator for quantifying emissions, and also a series of research work packages that complement or relate to the development of the tool in some way. The role of the University of Edinburgh Business School has been to lead on the research component of the project, and we've worked together with our industry partner, Costain Group, who've led on the development of the carbon calculator. The main target group for this study and the report is really the construction sector as a whole, and that includes everyone from clients, including government, down to contractors and suppliers and the people who produce low carbon materials within the sector. In terms of the findings from the research, there are a number of detailed findings from each of the research work packages, but to give a single or overarching finding, it's essentially that a collaboration is essential in order to reduce emissions within the sector. And another key theme or finding is that the client should ultimately drive reductions in emissions within infrastructure projects. One slightly surprising and interesting finding from the research was from the uncertainty analysis that was undertaken. And we found that with decisions that reduce greenhouse gas emissions, they also reduce the amount of uncertainty in terms of the range of greenhouse gas outcomes from the development of an infrastructure project. And that's slightly surprising because in other contexts, like in financial markets, when you pick a stock that has a higher return, often it also has higher volatility or uncertainty. Whereas what we're seeing with emission reduction decision making is that as well as reducing carbon, you also reduce uncertainty. Part of the research looked at the risk of burden shifting from the use of embodied carbon calculators. And burden shifting occurs when a decision might reduce emissions in one part of an asset's life cycle, perhaps in the embodied carbon phase, but then increase emissions somewhere else in the life cycle, for example, in the use phase or the end-of-life disposal phase. And we found that there were instances where the use of the CITT tool could lead to burden shifting. And so we developed a number of very simple heuristics to help to identify and manage that situation. And also we ultimately give the recommendation that future development of carbon calculators should really try to look at whole of life greenhouse gas impacts. And even moving beyond that, should also try to include what's called consequential life cycle assessment as well. So one part of the research looked at potential social and institutional barriers to the adoption of the tool and also to the adoption of carbon management practices more generally. And that research identified a very large number of different barriers or constraints. And to help organize and analyze those issues, we divided them up into what we call internal constraints, which were constraints that could be controlled by the organization in question, and external constraints, which were outside the control of the organization. And then also a third category was constraints that could be managed or need to be jointly managed by the organization and also external parties. And so, for example, an internal constraint was the way in which many organizations, carbon is dealt with by a dedicated team, perhaps a carbon team or a sustainability team, but it isn't mainstreamed in the organization. So one of the solutions that we identified to that particular problem was leadership within the organization. So leadership is needed in order to mainstream these carbon management activities. And again, an example of an external constraint was the need for the client to really take ownership and drive and demand carbon reductions when they commission and work through the development of an infrastructure asset. We also looked specifically at collaboration, and we looked at some of the challenges and also solutions to enhance collaboration. So the study that we undertook looked at a whole number of case studies of collaboration and identified a number of success factors. And that included things like information sharing, strong leadership, and also shared incentive mechanisms. And so one of the things that that piece of research highlighted as a way of achieving and ensuring those success factors was to develop a new kind of model for managing infrastructure projects. So instead of having a design, bid, build linear model, the research suggests that one solution is to have a very client-focused approach where the client takes a key role in working with contractors and suppliers throughout the delivery of the infrastructure asset. And that role can involve a number of different things, such as information sharing and education, but also looking at ways of incentivizing financially low carbon behavior. With regard to uncertainty analysis, what the research shows is that uncertainty analysis does give you a lot more information about the likely emissions outcomes from infrastructure projects. It's vitally important to understand whether a change in material use is just something that's within the margin of error of the emissions factors, or whether it's likely to be a real reduction in emissions. So our key recommendation from that work package is that future generations of carbon calculator, if you like, should look to include uncertainty analysis rather than just single point estimates. The next step from this study, I think, is really to move on to implementation. And that's really now over to the industry and particularly clients to focus on demanding low carbon infrastructure assets. The project team has consisted of academics from a number of different disciplinary backgrounds, and it's also consisted of academics and our industry partners. And that's given us a whole range of perspectives on the issue of carbon management within infrastructure. And working with an industry partner has brought huge benefits in terms of access to data and to personnel, and also a richness of understanding of the key issues in the industry, which we wouldn't have otherwise had. One final comment on the nature of this study and the findings we've had is that the funder, which was the Construction Climate Challenge, which is hosted by Volvo Construction Equipment, they played quite an active role in terms of asking questions and providing suggestions throughout the research. And reflecting on that, in a way, they took the kind of client-focused role that we identified as a very important one in terms of managing infrastructure projects, and they applied essentially that role to managing this research project. And it was very valuable in terms of teasing out new insights and finding other collaborations that would benefit the project.